Hi students, good morning. The chapter triangles is continuing. In that, just we have finished part 5. In the previous class, we studied that AA criteria for similarity of two triangles and SSS criteria for similarity of two triangles. Today, next part is SAS criteria for similarity of two triangles. Just I want to remind that AA criteria states that two triangles are equiangular, then the sides are in proportion, then the triangles are similar. And SSS criteria, in two triangles, corresponding sides are proportional, then the triangles are equiangular, then the triangles are similar. Today that is SAS. You can understand that two sides of two triangles are in proportion. Include angle of one triangle is equal to the corresponding angle of the other triangle. That is SAS criteria for triangles. Then the triangles are said to be similar. So today you want to prove about SAS similarity. Okay. So theorem states that, just I will write the statement, then we see now. Theorem. This property is said to be characteristic property of two triangles are said to be similar. First property is AA criteria, second property is SSS criteria, the third property is SAS criteria. Is it? So now, if the corresponding sides of two triangles are proportional. Two triangles are proportional and included angles are equal. Included angles are equal. Then the triangles are similar. Then triangles are similar. Yes, in the statement, if the corresponding sides of two triangles are proportion, included angles are equal. Very careful. Yes, two triangles are similar, not equal, similar, and included angles are equal, then the triangles are similar. Already we defined that sides are in proportion. Second condition is angles are equal. So when the two properties satisfied, at that time we are saying that the two triangles are similar, and this property is said to be SAS criteria for similarity of two triangles. So by the help of statement, if the corresponding sides of two triangles are similar, it is data, it is given. According to that data given, we are going to draw a rough idea. So that is ABC is one triangle, DEF is another triangle. We want to show that these two triangles are similar with the condition. Yes. So that is data are given in triangles ABC and DEF. What is given? What is given? AB corresponds to DE. AB by DE is equal to AC by DF, and angle A is equal to angle B. They are given. If you include angle are given equal and two corresponding sides are same ratio, you can get proportion. Is it? So then to prove triangle ABC is similar to triangle DEF. This is first work is to do that according to the statement. First work is to draw a rough idea. Then what is given or write, two corresponding sides are in proportion and input angle is equal. Then what to prove, that is to similarity what to prove. This is first part of the theorem. So if it is necessary to construct to prove, that construction you have to write. Okay. So now marking the point P on DE, Q on DF with condition, that is construction. Marking a point P on DE, Q on DF with condition that AB is equal to DP, AC is equal to DQ. This is construction. Understanding? Okay, that is construction. Yes, take a point P on DE and Q on DF such that, very important this is, such that there must be some condition. What is that? DP is equal to AB and DQ is equal to AC. Then join P2, join P2. So what is the purpose of to have the construction? Because already what you have proved, what you know about that, with the help of that we are going to prove. That is the purpose to have construction. You see? So now when you have constructed this, what you can tell about triangle ABC and DTQ? Already what you learned in your previous standard. So AB is equal to DP, AC is equal to DQ, angle A is equal to angle D. Is it? So by side angle side equal there. So these two triangles are congruent. These two triangles are congruent. So these two triangles are congruent means, with the help of AC is congruence. Congruence means at that time angle B is equal to angle P, or P is equal to E, or AB by DP equal there is equal to AC by DQ. Is it? So with the help of these, two sides are in proportion. Two sides are in proportion. So instead of that, what you can write? DP by DE. It means AB by DP, DP by DE, AB by DE. So in this way, we are going to apply the criteria to show that the two triangles are similar. Let's tell you right in the proof. Yes. True. In triangle ABC and triangle DPQ. Yes, triangle ABC, triangle DPQ. AB is equal to DP. AB is equal to DP by construction. Angle A is equal to angle B is given. That is data. And AC is equal to DQ. This is by help of construction. Therefore, angles side angle side equal there. Therefore, triangle ABC is congruent to triangle DPQ by reason what? By SAS congruence. By SAS congruence relation. Okay. Yes. Therefore, for this equation number 1. Yes. Now, AB by DE. AB by DE is equal to AC by DF given. Yes. So this is given. So AB equal to what we constructed? DP we constructed. AB equal to DP we constructed. So DP by DE is equal to AC equal to constructed DQ. That is DQ by DF. See, when you are observing that DP by, see now, DP by DE is equal to DQ by DF by the corollary of basic proportionality theorem. Sides of the new triangle form DP are proportional to the sides of the given triangle DE. Then Cornerstone theorem tells that PQ is parallel to EF. This is how we are going to use, how we are going to have constructed. Is it? So DP by DE is equal to DQ by DF. It implies PQ parallel to EF. PQ parallel to EF by corollary of BPP. Corollary, Cornerstone theorem can tell or corollary can tell. Yes, by corollary of BPP. Yes. Therefore, it implies PQ is parallel. PQ is parallel to EF. So, at that time, corresponding angles are equal. So, therefore, angle P is equal to angle E and angle Q is equal to angle F. Corresponding angles. Yes, reason is corresponding angles. We know that when the two parallel lines cut by the transversal, then the corresponding angles are equal. Yes. Then, in triangle DPQ and DEF, DPQ and DEF, DPQ, DEF, angle P is equal to angle E and angle Q is equal to angle F, and this is approved, and angle A is equal to angle D is given or common. Sorry, angle D is common. Angle D is equal to angle D is common angle. Angle D is common. Therefore, angles are equal. So therefore triangle DPQ is similar to triangle DEF by AA criteria. For this question number 2. So therefore S from 1 and 2, from 1 and 2, what one tells, ABC is congruent to DPQ. DPQ is similar to DEF. So ABC is congruent to DPQ. Congruent triangles are always similar. It means ABC is similar to DPQ. DPQ is similar to DEF. The things which are equal to same thing are equal to one another. So that property, triangle ABC is congruent means similar. It is similar to DEF. Therefore, triangle ABC is similar to triangle DEF. This is correct. Understanding anything? Yes. What is the first word? By the given statement, draw the rough figures to represent the given idea. Second part is what is going to prove, that you have to write. If necessary to have construction or construction. What is construction? The important point is P is marking on B. How it is? That must be equal to E. Q is marking on Q. DQ must be equal to E. So considering this triangle and former triangle, try to show them congruent. Yes. So by SAS, these two triangles are congruent. That is the first property. It means first part. Okay. Then AB by DE equal to AC by DF given there. Two corresponding sides of two triangles are proportional. And then with that what we have constructed here, AB equal to DP constructed, AC equal to DQ constructed. So DP by DE equal to DQ by DF. The same triangle we are taking. DP by DE is equal to DQ by DF. So when basic proportionality tells, if corresponding sides of two triangles are in proportion, then the triangle is parallel to the remaining side. So PQ parallel to EF. PQ parallel to EF. At that time, angle P is equal to angle E, angle Q is equal to angle EF. When we consider these two triangles, P equal to E, Q equal to F, D is common. So two triangles are equiangular. First criteria, AA criteria. By the AA criteria, these small triangle and big triangles are similar. Yes, and the small triangle is congruent. This triangle is congruent to small triangle, and the small triangle is similar to bigger triangle. So congruent triangles are always similar. So by the help of the axiom, you can tell these ABC and DF are similar. This criteria is said to be SAS criteria. So some examples we'll see about. Already have seen some examples about A criteria. So now criteria how we can use to solve the exam. Okay. A criteria is an example to solve. So now we have to see that SAS criteria and SAS criteria. Yes, ABCD is a trapezium with AB parallel to DC. Intersect each other at a point O. Using similar criteria for two triangles, prove that. To prove OA by OC is equal to OB by OD. Yes, what is given? What you have to prove? ABCD is a trapezium. Trapezium means one opposite sides of one pair of opposite sides are parallel. So AB is parallel to DC given. So to prove OA, OC, OB and OD. So here the thing is to identify OA, OC, OB, OD in which triangles they appear. First work is to understand. So OA, OB, OC, OD. Yes, these two triangles related to parallel sides. So here parallel sides are there. So parallel sides property we know. So therefore that we can understand that is consider AOB triangle and COD triangle. Then try to show that these two triangles are similar. To show the similarity, equivalent or SS or SSS. Among these three properties, one property must be satisfied by these two triangles. Then we can tell the sides are in proportion. Is it? Now, yes, ABCD is a trapezium. ABCD is a trapezium with AB parallel to DC. With AB parallel to DC. So this I will tell that. So parallel to DC means at that time DB or BD becomes transversal. So alternate angles are equal. Alternate angles are equal. Similarly, AC transversal. Alternate angles are equal. And vertically opposite angles are equal. Yes, these two triangles are equiangular. Then the triangles are similar. Then the sides are in proportion. Yes. In triangle AOB or OAB and triangle OCD. Yes. So OBA is equal to OBC. Yes. The reason is alternate angles. They given here. Yes. And angle OAB is equal to angle OCD. And third angle we can write or not? Two angles are there, that one it is AA criteria. Is it? So now, and angle AOB equal to angle COD, vertically opposite angles. So therefore triangles are equiangular. Therefore triangle OAB is similar to triangle OCD by what? AA criteria for similarity. AA criteria for similarity. Therefore, corresponding sides are in proportion. Therefore, OA by OC equal to OB by OD. OA by OC is equal to OB by OD. See, this way we are going to prove. Understand? So, very carefully to observe the figure and try to understand the relation. Yes, in the example, in the given figure, QR by QS equal to QT by PR, and figure 1 equal to angle 2 given. The question is PQS is similar to PQR. Okay. See here, there are some points of learning that is in triangle PQR. In triangle PQR, see that PQR. In triangle PQR, angle 1 equal to angle 2. It means base angles are equal. What the property you know about? In a triangle, if two angles are equal, then the sides opposite to equal angles are equal. So that property is used. So in triangle PQR, angle 1 equal to angle 2 is given. Therefore, PQ equal to PR. Very important relation. Sides opposite to equal angles are equal. And QR by QS equal to QT by PR is given. Calling this equation number 2. Yes, from 1 and 2, from 1 and 2, from 1 and 2, QR by QS, QR by QS, QT by PR, QT by PR, QT by PR equal to PQ, PR equal to PQ was proved here. So now, taking reciprocals, or it implies QS by QR equal to PQ by QT, reciprocals. Reciprocal, is it? Now in triangle PQS and triangle PQR, try to show them equiangular two corresponding sides are proportion, one angle is equal, R by SSS criteria. Among these three criteria, one of the criteria must be satisfied by these two triangles. You see now, yes, QS by QR equal to PQ by QT, and angle 1 is equal to angle 2. See now, QS by QS is the side of a triangle PQS, QR is the side of a triangle PQR, PQ is the side of the triangle PQS, QT is the side of the triangle PQR, and angle 1 is related to PQR, angle 2 is related to PQS, angles are equal. So by two corresponding sides are in proportion, one angle input angle is equal. By SAS criteria, these two triangles are similar, is it? Therefore, by using SAS criteria, triangle, what are those? PQS is similar to triangle PQR. Yes, and this is it means very carefully. What point is here in this example? 1 equal to 2. If 1 is not equal to 2, at that time not question. So very careful about given ideas, given things. So 1 equal to 2 by the help of already studied that sides opposite to equal angles are equal. So with the help of we are doing that by SAS rule means two sides are in proportion, input angle is equal. So angles are similar. So in this way we are going to use the criteria for similarity of triangles. Yes, we will see some more examples related to these SAS, SSS, criteria.